All right, and here we are with our last homework help problem, and this is touching on some ideas from chapter 1 that we thought maybe we had left behind, right? And so this is asking us about revenue functions and marginal revenue, and we gotta kind of rehash some of this stuff, right? So the first thing it says is find a revenue function in terms of price. And so what the problem gives you that helps you do that is it tells you the quantity you will sell as a function of price. And so what this says is like, if I set my price equal to $1, I can put in that price here, and that tells me how many units I sell, right? So it's basically like, think you're selling Big Macs, and it's like, well, how many Big Macs am I going to sell if I set the price equal to $1? And this is the function that tells you that, right? If you set your Big Mac to $2, you can plug in a 2 here, and then your Q will be how many Big Macs you would sell if your price was $2. And so the first question is, what is the function for revenue in terms of just price? All right, and so think about what we remember about revenue from before. Revenue was the price of your product, kind of how much you were selling it for, times the number you sold, right? And this makes sense, right? If your Big Mac was $2 and you sold 100 of them, you would make $200, right? But the thing they give us here that's a little bit more helpful is we have this Q. And so this tells us our quantity that we're going to sell in terms of price. So we can insert this in for Q. So we're going to insert that whole function in, 1300 e to the negative 0.02 p. And that's our revenue function. And we can simplify this a little bit more, maybe. I mean, really, we're just kind of reordering some of the terms. So it'd be 1300 p e to the negative 0.02 p is probably how I normally would write it. The next question asks us to find the marginal revenue. And our revenue functions used to usually look something like this. Like our revenue would be equal to, if my Big Mac was $2, it would be like equal to 2Q or something like that, right? It wasn't always in terms of price, and it was in terms of Q. And the point is, though, when we asked for marginal revenue before, we were asking for slope. They always gave us linear equations. That we don't have a linear equation here, so how can we ask for the slope of this revenue function? And the way we can do it is we can actually use the derivative, and they kind of cue us into that, right? They say, well, take the derivative. And all I'm trying to emphasize is it's the same concept we know from before. Marginal kind of has to deal with how much revenue you gain from the next unit, right? And in this case, we're talking about increasing the price. So anyway, long story short, we take the derivative here, and this derivative is going to be a product rule, right? So we'll have f here, we'll have a g here, and so if we take our derivative function, we want f prime g plus f g prime. So f prime is just going to be 1300, and then g, because we're taking the derivative of 1300p, g is just going to be left alone for that one, negative 0.02p. Now we leave f alone this time, 1300p, and we're multiplying this by g prime. And notice that this is e to the kt, so the derivative is k e to the kt, and we'll do negative 0.02, not 20, 0.02 e to the negative 0.02p. Okay, put this prime a little bit closer to there. And so this is what we could enter to get our marginal revenue. And so when it says when p equals 7, so when you set your price of your Big Mac equal to an outrageous $7, how much revenue are you getting? And so all you have to do is come up to this function and plug it in. That tells you your total revenue, right? So you could plug in 1300 times 7 e to the negative 0.02 times 7, right? You could plug that into your calculator and get an answer. What about the marginal revenue? How do we get that? Well, we're just going to plug it into our derivative. This is r prime of 7, right? This one is r of 7 is equal to, so r prime of 7 is equal to, we'll plug in a 7 there, right? So in this case, that would be 1300 e to the negative 0.02 times 7 plus 1300 times 7 negative 0.02 times negative 0.02 e to the negative 0.02 times 7. And so this unit, the units of this derivative here, notice that we're looking at dr over dp, and so this is like when we get this out in our calculator, we can type it into our calculator and get about $971.94. And so what this is, the units of this are dollars in revenue per dollars in price. And so what this is saying is if you raise the price about $1, you should expect to increase your revenue by about $971.94. Because what we're talking about here, remember, what we're looking at is we're looking at price on the x-axis, revenue on the y-axis. And so the slope, the marginal revenue, is terms of dollars per revenue per dollars in price.